NASA held a highly anticipated press conference on November 19, 2025, providing the public and the scientific community with unprecedented insights and breathtaking images of Comet 3 I/Atlas, one of the most intriguing interstellar visitors ever observed in our solar system. This event attracted widespread attention, both from space enthusiasts and from curious individuals who had been following the comet's progress closely through social media and astronomy forums. The press conference was opened by NASA Associate Administrator Amit Kshatriya, who began by addressing the swirling speculations and rumors about the nature of this mysterious celestial visitor. Kshatriya reassured the public that, despite the intense curiosity and occasional sensational claims circulating online, Comet 3 I/Atlas is firmly classified as a comet. It is not, as some had suggested in viral posts, evidence of extraterrestrial life or advanced alien technology. This clarification was particularly important given the context of previous sensational claims regarding interstellar objects and the persistent fascination humanity has with the possibility of alien visitors. By establishing that the object is a comet, NASA aimed to maintain scientific accuracy and calm public anxieties while emphasizing the profound scientific value of observing such an object originating from outside our solar system. Following this reassurance, the conference transitioned to the main highlight, a series of high-resolution images captured by multiple NASA spacecraft and space telescopes. These images provided both stunning visual detail and invaluable scientific data, offering a rare glimpse at a comet from another star system interacting with the Sun's gravitational and radiative influence. Comet 3 I/Atlas holds a special place in astronomical history as only the third known interstellar object to enter our solar system, joining the ranks of the first interstellar visitor, 1 I/Oumuamua, discovered in 2017, and the second, 2 I/Borisov, discovered in 2019. Each of these rare visitors provides astronomers with a unique opportunity to study material that formed around other stars, allowing for comparative analysis with our own solar system's comets and asteroids. Unlike these previous visitors, Comet 3 I/Atlas has benefited from an unprecedented concentration of observational resources, allowing scientists to capture its approach, perihelion, and ongoing movement with far greater clarity. One of the most remarkable contributions to this effort came from NASA's Mars Reconnaissance Orbiter, MRO, which turned its high-resolution imaging science experiment, HiRISE, camera toward the comet during its close approach. On October 2, 2025, when the comet was still 19 million miles from Mars, HiRISE captured a detailed image that allowed scientists to study the structure of the comet's nucleus and its developing coma and tail. The MRO's observations were particularly valuable because the spacecraft was able to view the comet from a unique vantage point, relatively close to the Sun and Earth, yet far enough from Mars to minimize interference from the planet's atmosphere and magnetosphere. This imaging provided critical data for understanding how the comet's materials, likely formed billions of years ago in another star system, react to solar heating and the intense solar wind during perihelion. The resulting images not only demonstrated the comet's classic tail and coma features, but also revealed subtle irregularities and asymmetries that will likely fuel ongoing research and modeling efforts for years to come. In addition to NASA's spacecraft contributions, amateur and professional astrophotographers around the world played an extraordinary role in documenting Comet 3 I/Atlas. Photographers such as Michael Yeager, Gerald Riemann, and Enrico Prosperi captured early images of the comet as it emerged from its closest passage near the Sun, which occurred on October 29, 2025. Their work offered an immediate, accessible window into the comet's beauty and dynamism, complementing the data collected by spaceborne observatories. These images, shared on social media platforms such as the ICQ Comet Observations Facebook page, allowed not only scientists, but also telescope users and amateur stargazers to witness the comet's intricate tail structures, the glow of its coma, and subtle shifts in its trajectory caused by solar heating. This public sharing of high-quality astrophotography emphasizes how collaborative efforts between professional and amateur communities can enhance scientific understanding while inspiring global curiosity and engagement with astronomy. The release of these images also underscored the dramatic changes that occur when a comet from another star system passes close to our Sun. As with all comets, the proximity to the Sun triggers sublimation of ices on the comet's surface, producing the characteristic glowing coma and the streaming tail. In Comet 3 I/Atlas, scientists observed variations in tail direction and density, indicative of the uneven distribution of volatile materials within its nucleus. This behavior provides important clues about the comet's composition, internal structure, and thermal history. The ability to monitor these processes in an interstellar object adds a remarkable comparative dimension to cometary science, offering insights into how such objects evolve differently from those formed in our own solar system. For researchers, each image is more than a stunning photograph. It is a dataset filled with information about the chemical composition, dust production rates, and potential changes in orbital dynamics caused by solar radiation pressure and outgassing effects. Furthermore, the press conference emphasized the extraordinary observational coordination that NASA and the global astronomy community employed to study Comet 3 I/Atlas. Multiple telescopes, both space-based and ground-based, were utilized to track the comet's position, brightness variations, and tail morphology over time. The integration of data from observatories such as the Hubble Space Telescope, the James Webb Space Telescope, and various planetary orbiters allowed scientists to cross-validate findings and produce a coherent understanding of the comet's physical and chemical properties. The MRO's proximity-based imagery, when combined with these other observations, created a comprehensive, multi-perspective portrait of an object that had previously only been a distant point of light. This level of observation is unprecedented for interstellar visitors, highlighting the growing capability of humanity to study transient celestial phenomena in extraordinary detail. Beyond its scientific implications, the event also offered the public a sense of connection to a vast, dynamic universe. Images of Comet 3 I/Atlas not only illustrate the physical properties of the comet, but also tell a story about cosmic journeys spanning light years, as the comet traveled through interstellar space before entering our solar system. Each bright streak of gas and dust, every subtle feature in the tail, and the faint glimmer of the nucleus represents a fragment of material forged in a distant stellar nursery, carrying with it the chemical fingerprint of an alien system. The public's fascination, fueled in part by the sharing of photographs and videos online, reflects a deep, intrinsic curiosity about our place in the cosmos and the mysteries that lie beyond our solar neighborhood. NASA's careful, transparent communication during the press conference helped channel this excitement in a scientifically accurate way, balancing wonder with fact. The collaborative nature of this observational campaign demonstrates how modern astronomy relies on a combination of professional expertise, public engagement, and advanced technology. The high-resolution images released during the press conference are a testament not only to the capabilities of sophisticated instruments like HiRISE, but also to the skill and dedication of observers like Yeager, Riemann, and Prosperi, who capture and share these moments with the world. These combined efforts allow both experts and enthusiasts to follow the comet's journey across the sky, study its unique behavior, and appreciate the stunning visual spectacle it creates. As the comet continues on its path out of our solar system, astronomers will continue to analyze the data, publish findings, and compare its characteristics with those of previous interstellar visitors. Each step forward enhances our understanding of planetary formation, cometary evolution, and the diversity of material in the galaxy. In conclusion, the November 19, 2025 NASA press conference served as a milestone in the study of interstellar objects, providing both a scientific and a visual feast for the public and the astronomy community alike. By clearly defining Comet 3 I/Atlas as a comet, NASA set a factual baseline that countered misinformation and speculation while emphasizing the extraordinary value of this rare interstellar visitor. The high-resolution images captured by spacecraft like the Mars Reconnaissance Orbiter, complemented by the stunning work of skilled astrophotographers, offered unparalleled insight into the comet's physical structure, chemical composition, and dynamic interaction with the Sun. These combined observations illustrate the growing capabilities of modern astronomy to study transient and distant phenomena in unprecedented detail. As the comet moves away from the Sun and eventually out of the solar system, the data collected during this brief window of opportunity will continue to inform and inspire researchers, amateur astronomers, and the general public for years to come, reminding us once again of the beauty, complexity, and scale of the universe we inhabit. The press conference was not only a presentation of scientific achievement, but also a celebration of human curiosity, international collaboration, and the awe-inspiring nature of interstellar exploration.